Welcome to CW 2.2. To start us off, let's look at this simple question. 4 divided by 25. So we know that will go into it 6 times. We multiply, subtract. So we have a remainder of 1. But we're going to label these terms. So 25, this term is called the dividend. 4, that is called the divisor. 6 is called the quotient. And this 1 is, of course, your remainder. So the reason I'm telling you those vocab words is because we want to actually combine all of them to make some type of equation. So watch what I do here. The dividend, that's our 25, that's actually equal to the quotient multiplied by your divisor. So imagine you have your 25 right here. We're saying 25 is equal to 6 times 4. And look at how this remainder 1 plays into it. Just want to add it at the end. So plus your remainder. So we can actually think of division as some algebraic process like that. Now the reason we're doing that is because now we're going to plug in some algebra. Let's get rid of these. Let's say we work with some function. Let's call that function f of x. The quotient is what we're trying to solve, right? That's like our answer at the end. But the divisor, let's say that the divisor is actually this thing x minus a. And the remainder, of course, we don't know that quite yet. So we can actually think of the division problem we had, or the division in general, to be something like this. Now let's see what happens if I do this. Let x equal a. I get f of a is equal to our quotient times a minus a plus the remainder. But look at this, a minus a is 0, which means this thing doesn't matter, which means f of a becomes the remainder. Okay, now you're probably wondering, why did we do all that? This is actually an interesting find, because that would mean if you want to find the remainder, we can just use this, f of a. So this takes us to the remainder theorem. So let me write this out for you. Remainder theorem. What the remainder theorem says is that given f of x divided by x minus a, f of a is the remainder. And that's actually quite powerful, because that would mean if f of a equals 0, meaning there was no remainder, then x minus a is a factor of f of x. So for now, if this is still, again, kind of blurry, that's okay. This part we're not going to use quite yet. We're going to focus on the remainder portion. So I'm going to show you what this all means right now. Let's say for this problem, I just said find the remainder. And it's divided by x minus 2. Okay, so here's f of x. We're dividing it by x minus 2 here. What you would normally do is put your 2 right there, write your coefficients out, and work it out. So I'll do this really quickly. So right there, remainder is 5. That's what we do from last class. With the remainder theorem, what we're saying is we're dividing it by x minus 2. So if you want the remainder, simply let x equal 2. Let's just find f of 2. So that would be 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. If the theorem is correct, this should come out to the number 5. So let's see what happens. That's 8 minus 16 plus 10 plus 3. That would be negative 8 plus 13. And look, it is 5. So it does actually work. So we'll do one more just to make sure you guys got it. It says, given this thing, find the remainder when you divide by x plus 4. So again, we can do it the old-fashioned way just to do a quick check. There's negative 4, 3, 4, negative 5, and 3. I'll do my synthetic division quickly here for you. So feel free to pause if you need to do this on your own. I'm just going to write the numbers down. That's negative 105. So there's our remainder. So now here's the remainder theorem. The remainder theorem says we can just plug in whatever makes this thing equal to 0. So we're going to find f of negative 4. So if I were to plug that in, it'd be 3, negative 4 to the third, plus 4, negative 4 squared, minus 5, negative 4, plus 3. And just to save you time, if you were to work that all out, you do in fact get negative 105. Same exact thing. Okay, so that's the remainder theorem. Now the reason the remainder theorem is powerful is because of this part I highlighted. This part I highlighted is actually called this, the factor theorem. And the factor theorem is simply just an extension of the remainder theorem. It's what I'm saying right here, is that if the thing you plugged in is 0, then you actually found a factor. So again, that's all it means. If you plug something in and you get 0, then you found a factor. So let's kind of show you what that means. It's saying solve the equation right here, given that 3 is a 0. So let's highlight that. 3 is a 0. So if 3 is a 0, what that means is f of 3 is equal to 0. So what you can conclude from that is x minus 3 must be a factor, which means I can do my synthetic division. I can use 3 because that's my 0. Let's plug everything in. And let's quickly do some synthetic division. Drop the 2, multiply, add, multiply, add, multiply. And of course, we get a 0. And this has to be 0, right? Because it told us that it would work. So if you didn't get 0 here, that means you made a mistake. Now from here, we're going to put all these numbers in context. What we just found is that this thing is 2x squared plus 3x minus 2. And if this is multiplied by x minus 3, this is this expression. So this thing is now equal to 0, because that's what we're ultimately trying to do. We're trying to solve this equation right here. So now we're putting all your tools together. Notice how we knew this fact, f of 3 equals 0, which means here's our synthetic, here's all our work. And that allows you to factor something much more complex. Notice how you are now able to solve this question without a calculator. Now we just keep going. Let's factor that second piece right there. That would be 2x minus 1, x plus 2. So x would equal 3, 1/2, and negative 2. Now it did give you 3, but it's a good habit just to write it here just to make sure you don't forget. And that's it.